thank you. Hello, guys. So, as the moderator has already pressed my name, let's get right into it. So, the idea of this presentation is to how we can blend virtual and augmented reality in educational materials and to find the efficient way, the most efficient way to do that. So, the motivation, firstly, is that since 2004, the concentration has fallen by drastically 1/5 of what it was in 2024. Now, the goals of this paper is to quantify the level of concentration and to train and see if a machine learning model can actually classify it and see to find an easier way of classifying it. The materials for the study were 16 subjects, a ratio between genders of 1 and 1. And after they were aged between 8 to 17 because this was the age that produced the most problems. They suffered from some visual problems as well. We've used an EEG headset brain access MIDI with 60 channels based on the 1020 system with a 250 hertz frequency. The VR headset used was an MetaQuest 3. And so let's talk about methodology. So firstly, we quantify the concentration using the concentration index, which is the index power of the beta band plus SMR over theta. After that, we've put our subjects through the test on short-term visual, auditory, critical, and linguistic thinking and quantified their results. Furthermore, we've even recorded some baselines to know from where to look at the concentration increases. After the methodology, we took the raw data and started pre-processing it for the machine learning model. So firstly, we put it through some low-pass, notch, and high-pass filters so that it will be easier for us to eliminate the unnecessary bands, to eliminate the DC power, and to get rid of other stuff. After we've decomposed it using independent component analysis, classified it using IC labeling, and reconstructed it, eliminating the noise. After we've extracted some feature using common spatial patterns, and there you go, you have clean data. After pre-processing and extracting, we fit it through some artificial intelligence models so that we will be able to see how all of them are acting on classifying between virtual, augmented, and real-world environments. Whew. As for results, we've obtained that VR environment helps increasing the concentration by 57% compared to virtual reality. This is very important because after this study, we can assume that making an application that toggles between real and virtual world would help more than virtual reality or real world. After training the models, we observed that it had no problem differentiating between virtual and real world with an accuracy of over 95%. But moreover, if you add augmented reality in this equation, it comes some problems because the ratios of accuracy will become 1:1:1, which makes a problem. And so we've conducted to this phenomenon called augmented ARP, which states that, in our opinion, that the virtual and real world environments are taught as a combination in our brain and influence how AR is perceived. So augmented reality is not one thing of its own, but it's a combination of both of them. That's how the brain perceives it based on our data. And here we have a video how we demonstrate you using our platform for how we record the data. So here we've recorded some visual exercises, giving a video to relax them at first. Here you can see the user logging into our platform. Here they are choosing a video, for example, on dark hole ones. After seeing that they are not concentrated, it will start beeping. And after that, we can start recording the data. Here there are stats because we've wanted to use our public and even show them how they're performing to help increase their concentration in time. And that's it. Thank you for your attention.